Hello, good to see you again. Welcome to Block 1, Solving Problems with Addition and Subtraction. Lesson 13. I'll share my screen. All right. So, in your previous lesson, you learned how to solve problems with bar charts and line charts. It was an interesting lesson where you learned how to interpret different bar charts and pie charts. In today's lesson, you're going to learn how to add and subtract numbers given in standard form. But before we start, I want to ask you to like the video, subscribe to the channel, share the video with people you think can benefit from it, and click on the notification bell so that when new videos are released, you will be notified. By doing this, you help us grow our mission, which is to provide free, accessible education to the global population of children who may not have the financial resources to have to pay for high quality maths education. Thank you. All right, before we start, I would like you to do the retrieval practice question in 3 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. Let's discuss them. So for the first one, the answer is 3 times 10 to the power 5. If you do not know how to express numbers in standard form or powers of 10, the link will be attached to this video so that you can use that to revise or review your learning. Next, 320 million is going to be 3.2 times 10 to the power 8. 27 hundredths is 2.7 times 10 to the power negative 1. And then question 2, write the following numbers in ordinary form. That will be 9 million, and that will be 0.08. All right, let's do some new learning. Amir wants to find the difference between 5 times 10 to the power 3 and 2 times 10 to the power 3. Here is what he writes. Do you think this is correct? Of course not. The mistake he has made is 5 times 10 to the power 3 is 5,000. And 2 times 10 to the power 3 is 2,000. So 5,000 minus 2,000 is 3,000. So your answer should actually be 3 times 10 to the power 3. Have you noticed something with the power when we subtract it and because we have the same power? Just take note of what you think is going on. Let's look at another example. 3 times 10 to the power 4 plus 4 times 10 to the power 4 will be this. So that is 30,000 plus 40,000, which will give us 70,000. In standard form, that is 7 times 10 to the power 4. Okay, 7 times 10 to the power 4. Now, what do you notice about the power? So, have you noticed that when the powers are the same, the answer has the same power as well? So we simply just did the calculation for the first, integers of the standard form. What about this one? What would you say the answer is? Would you say it is 1 million? Of course, it's correct. It's 1 million. But if we write it in standard form using this, where we said, okay, if the powers are the same, we can simply just add the first integers, the integers of the standard forms. So if we do that, this will be 10 times 10 to the power 5. But is this in standard form? Of course not. So your answer must be in standard form, which is actually 10 times 10 to the power, 1 times 10 to the power 6. Okay. Why is that the case? Of course, we'll learn some more when we start to do standard form conversion. All right, it's now time for you to have a go at questions 1, 2, 3. So what you've practiced so far is using your knowledge of knowing how to work with standard forms. When the powers are the same, you can simply just add or subtract the integers next to the powers of 10 for each of the standard form numbers. Okay? Now be careful, if the answer is not in standard form like this, you must put the answer in standard form. All right? So question 1, pause the video and answer question 1 in 2 minutes. Assuming you've paused the video and you've answered question 1, here are the answers. So mark your work and celebrate your success. So by now, you should know how to convert ordinary numbers to standard form and standard form to the equivalent ordinary number. Pause the video and answer question 2 in 3 minutes. All right, assuming you've paused the video and you've answered the questions, here are the answers. So here you ask, convert the numbers to ordinary form and find their total to show that Tommy is incorrect. All right. So if you convert them to ordinary form and you add them, you'll have 7 times 10 to the power 5. All right. So take note of that. Next, complete the calculation. Write your answers in standard form here. The powers are the same. So these are easy calculations. All right. So the powers are the same. So the powers will stay the same in your answer. You just need to focus on the first integers next to the standard form in the standard form numbers. Okay. Pause the video and answer question 3 in 2 minutes. All right. Assuming you've paused the video and you've answered the questions, here are the answers. Okay. You're asked to convert the numbers to ordinary form and find their total to show that Alex is correct. Okay. You just needed to convert it to ordinary numbers, add them, and then write your answer back in standard form. Next, B, discuss with your partner why the index has changed from adding the two numbers. It is because if we add them, the index will change because we have one more power of 10. Okay? So if we were to do this calculation, it will simply be 10 times 10 to the power 5. So let's write it. So it's going to be, so if we were to write it out using our first, so we know the powers are the same. So it's going to be 10 times 10 to the power 5. But this number here, this 10, is actually the same thing as 1 times 10 to the power 1, all right, times 10 to the power 5. Now, I'm not going to tell you about this yet, but I'm going to give you a little secret. Because these two are multiplying each other, these powers of 10, we're going to add them, okay? So your answer is 1 times 10 to the power 6. All right, so we did some work on powers of 10. So like I said, The video is going to be linked to this video. All right, let's move on. Well done. Keep at it. Let's keep learning. All right. So next one, you ask, complete the calculations. Okay. And the calculations are given to you here. All right. So again, remember, when the powers are not the same, it will be useful to convert the numbers to ordinary form before you add or subtract them. All right. This one would be a case of doing this minus that one to get this number. Okay. This minus that one to get the number in the box. All right. Let's look at a new example. Okay. Just a minute. Sorry about that. Okay. Okay. So for this one, here we want to work out 2 times 10 to the power 5 plus 5 times 10 to the power 7. Now, to be able to do this, we just need to change, okay, the number to, yeah, we'll see that the numbers are not, you see that the numbers, the answers are neither correct. So neither this one nor this one. This is the case where it is important to change your numbers to ordinary form before you add them. All right, here is this one. Okay, so this one, we have a snail travels at 5 times 10 to the power negative 2 kilometers per hour. A slug travels at 3 times 10 to the power negative 1 kilometers per hour. We're told to find the difference between their average speeds. So here, the way to do it is we can convert them to ordinary numbers. That's 0.3, and then that's 0.05 before we do our subtraction. And then that's our answer. Here is another example. We know how a part-whole model works. Now, what we need to do to get this will be to convert these to ordinary numbers. We know that these two will add up to get the number in the top of the part-whole model. So it will be that number minus that number, which you can see here, will give you that number. Okay, and then you were told to give your answer as ordinary form, so you do not need to write the number as standard form. All right, so what have we learned so far? So we have learned that you can convert numbers to ordinary form before you do your standard form calculation, which is to add or subtract. And then when you finish, if you have been asked to write the number in standard form, you can then rewrite the number back in standard form. Okay, it's time for you to practice the other questions. So here are the questions for you to practice. So pause the video and answer question 4 in 4 minutes. Assuming you've paused the video and you've answered question 4, here are the answers. Okay, here, if you convert to ordinary form before you add them, this is what you get. Yeah, and these are the answers. So mark your work and celebrate your success. If you got anyone wrong, you can do your correction and learn from your mistake. Here is number 5. The table shows the approximate distances in kilometers between Earth and some of the other planets. Distances are rounded to one significant figure. So write your answers in ordinary form. How far is Venus from Jupiter? Okay, so by now you should know how to read this mileage chart. We saw it in our previous lesson where we were looking at various tables. So between Venus and Jupiter, so we go down Venus and then we go long Jupiter. That's that one. Then we have to write our answer in ordinary form. Okay, pause the video and answer this question in 4 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. So mark your work and celebrate your success. All right. So here is questions, answers to questions C and D. So mark your work and celebrate your success. And that brings us to the end of the lesson. So this is the end of block 1 lesson. So we'll be moving on to block 2. So what have we learned so far? So we have learned that you can add or subtract numbers in standard form. If the powers are the same, you can simply just add the first numbers, which are written next to in the standard form number, and then the power will be the same in the answer. So for example, 2 times 10 to the power 3 plus 3 times 10 to the power 3 will be 5 times 10 to the power 3. Okay, but if the powers are not the same, it is much better to convert the numbers to ordinary number, do your addition or subtraction depending on what you've been asked to do, and then convert your answer to standard form. Really well done for sticking around and for learning today. Until next time, take very good care of yourself, and bye-bye.